All right, so in this video, we're looking at an AP Precalculus FRQ. AP Precalculus is a brand new course, just debuted in the fall of 2023. And of course, you have 40 multiple choice questions on the AP exam and 4 free response questions. One of those free response questions is a sinusoidal problem. It's a situation that can be simulated by a sinusoidal graph, and some common things they ask you. It's a pretty easy problem to navigate, to be perfectly honest. And so we're going to just dive in and do an example. And as we do an example, we'll point out the important things to take into account when doing such a problem. This problem, at all the information that has been released thus far, generally appears to come on number 3 of the FRQs, and it's a non-calculator problem. All right, so I have a sample problem similar to how these look. So let's go through it and kind of go through the basics. So this is a Ferris wheel here, and I'm just going to kind of read the problem and point out the important information. So a Ferris wheel has 40 cars. At time t equals 0, car number 1 is at the highest point, 80 feet above the ground. At the time t equals 1.5, car number 1 is at the lowest point, 10 feet above the ground. The sinusoidal function g models the distance from car number 1 to the ground in feet as a function of time t in minutes. Okay? So when you read these problems, definitely thing to pay attention to is when the situation is at its highest or lowest point, and at what time, or farthest to the right or farthest to the left, whether extremes or what times they occur. Sometime it will mention how long a full rotation happens. And so that will help you, determine, of course, the period of the sinusoidal function. This one doesn't mention the time of the rotation, but it does mention, the time from going from the highest point to the lowest point. That would be half of a period. If you look at any sinusoidal graph going from the max to the min, it's going to be half of a period. So it can be deduced from that particular information. So basically, from the information they're going to give you in the reading, and here they told me the highest point 80 feet, the lowest point 10 feet. From the information, I can easily deduce the amplitude. Its center point, where it's vertical translation, and the phase shift and all that. And that's kind of all the information they want to give us. They want to get from us. So let's continue and actually look at the problem that they're asking. So first, it says the sinusoidal function g models the distance from car 1 to the ground in feet as a function of time t. I think I already read that. So actually, I'm looking at problem A. So the graph of g and its dashed midline for 2 full cycles is shown below. Determine the possible coordinates of t, h of t for the 5 points F, G, J, K, and P. And so they'll give you this graph, and we're going to indicate the points, the x coordinate and the y coordinate, or the t coordinate and the h of t, as I call this h of t or g of t. The t coordinate and the h of t coordinate of the particular function. And as you look at the sinusoidal graph, so here's kind of how you attack this aspect of the problem. This guy where F and P are, those are, of course, the highest points. And this guy where J is, that, of course, is the lowest point. G and K are at the midline. Now, in this particular problem, I want to go back to reading and make sure I'm correct, but I believe it said at time t equals 0 is at its highest point at 80. So right here, at time t equals 0, car number 1 is at its highest point. So that means what I can do, let's point right here, F, the time that occurs, the t coordinate is 0, and of course, the h of t coordinate is 80. You see, it's pretty easy to manage. Now, there's one thing to be careful about, something that's gotten some students. Let's say hypothetically they said at time t equals 0, car number 1 was at its lowest point, right? At time t equals 0, car number 1 is at its lowest point, which I believe the lowest point was 10. Now, a common mistake would be come here to point J and put the coordinates of point J at 0, 10. That would be wrong. Why would that be wrong? Because if I put point J if I put the t coordinate at 0, then what can I put for the t coordinate at g and at f? Because time can't be negative. So that's a very important thing to keep intact. So again, if they ever say at time t equals 0, it's at its lowest point, I can't designate j at time t equals 0, because again, it will give me a negative t value for g and for f. And so how do I deal with that problem? So if it ever says at time t equals 0 is at its lowest point, you just calculate when the next full rotation occurs. So say rotation occurs every 2 seconds, and then you'll let this guy, this t guy, the t coordinate here be 2, but the t coordinate j cannot be 0 for the reasons explained. But if it's at the highest point, I can definitely make that 0. All right, so this is at 0, 80. Now again, it said in the problem, it's going back to the reading, it said at time t equals 1.5, card number 1 is at its lowest point. Okay, so the lowest point is here at j, and that will be 1.5. And I believe it said 10, I'm pretty sure. Let me go back just to make sure. Yeah, at 10 feet. All right. Once you got f and j, all the remaining guys can be deduced with fairly easy logic. Sometimes based on the situation, you'll quickly get f and p, and then the others can be deduced, very easily, because sometimes they'll say it's at its highest point, and then they'll just mention how time it takes to get a full revolution, a full rotation. Let's say it said it was at its highest point at time t equals 0, and it says it makes a full rotation every 3 seconds. Then I know, at point P, it's going to be 3, 80. And then if I know F and P, I just get the middle of that guy to get the t coordinate for J. And if I know F and J, I just get the middle of that guy to get the t coordinate for G, etc. So the rest of those can be done fairly easily. So I'll use that same logic to get the t coordinates for G. Again, G is in the middle here of F and J, so I'll just get the midpoint, just adding these and dividing by 2. So 0 times 1.5 divided by 2, that's 0.75. So the t coordinate for G is going to be 0.75. And again, going from F to G is half of a rotation. Going from F to P is a whole rotation. So if going from, I said F to G, I mean F to J. So going from F to J is half a rotation, or half of a period. And going from F to P is a whole rotation, or 1 full period. So if it took 1.5 seconds to do half of the period, that means a full period from F to P would be 3 seconds. So this would be 3. And of course, this y coordinate, or this h of t coordinate, is 80. Now, again, the same way I got the t coordinate for G, I get the t coordinate for K by simply getting the midpoints of the t coordinates for J and P. And so that's 1.5 plus 3 divided by 2. That's 4.5 divided by 2. It's 2.25. Now I close this one, not sure why. I got to get the t coordinate for J and K. J and K are at the midline. Sometime I'll give you what the midline is. In this case, it didn't. So the midline is basically, we have a very easy formula to find the midline. Sometimes we call it the vertical translation or the vertical shift of a sinusoidal graph. And you can get that number by simply adding the max and the min and dividing by 2. Because essentially it's same midpoint formula, just time, it's the y coordinates. So this is 80 plus 10, that's 90 divided by 2, so that would be 45. So the midline coordinate for the h of t value would be 45. If you ever want to check if this is accurate, it should be in the middle. So if you get the distance from it to the bottom and the distance from it to the top, it should be equal distance. And from 10 to 45 is a difference of 35. And from 45 to 80, it's a difference from 35. And so therefore, it works. All right, so that's going to be the first part of this FRQ. We'll stop there. In the subsequent video, we'll look at the other aspects of this problem. Thank you, and we'll see you next time.